here we go. So this right here that we talked about is something you learned about in school already, probably, unless you live in a region where you really don't have very noticeable seasons. And that's okay. But what we need to talk about now is something that people get screwed up on a lot, which is, why is the summer hot? Okay? Why is the summer hot? Okay? So let me ask you this. We just said that it's summer when the North Pole is tilted towards the sun. So why is it hot in the summer? Why is it hot? Why does this make you hot? Give me a guess. Why are we hot in the summer? It's definitely because the North Pole is tilted towards the sun, but why does that make it hot? There's one particular answer that I'm hoping to hear here, because it is not actually right. So you guys aren't given the wrong answer. So here's the wrong answer. Here we go. Here's the wrong answer. A lot of people think that the reason that we are, oh, you guys keep on giving me right answers. You guys, here we go. Here's the wrong answer. A lot of people think that the reason that the summer is hot is because we are closer to the sun in the summer, okay? Being tilted towards the sun does not necessarily mean we are closer to the sun, okay? In fact, this picture I drew, it's a little distorted, right? It's not a true picture of our orbit, because remember, the sun is not actually perfectly at the center of our orbit, right? Remember, according to Kepler's laws, it's at a focus. So it's not perfectly at the center, it's actually a little bit off to the side. Now, which side is it actually closer to? Check this out. The sun is actually, let me draw another orbit. If this was summer and this was winter, so winter, this is summer. Sorry for my handwriting right now. The sun is actually right around here. So what season are we actually closer to the sun in? Summer or winter? Which season are we closer to the sun in, according to this? Yeah. Because of the shape of our orbit, and because the sun is not perfectly at the center, it's off at the focus on this side, the month that we are actually absolutely closest to the sun in is January. January is the closest point to the sun. So it can't be the distance to the sun that makes it hot, because if we're closest to the sun in January, then that means that January should be the hottest month of the year for everyone, because we're we're thousands and thousands of miles closer to the sun on that month. So the distance to the sun is not what it is, okay? Now, it does have an effect on us. It does have an effect on us. Check this out. Don't overthink this. If we're closest to the sun in the winter for the northern hemisphere, if we're closer to the sun than we usually are, what's that going to do to our winters? What's that going to do to our winters? If we're closer to the sun than we usually are during winter, what will that do a little bit to the temperature of the winter that we experience? What's going to happen? Our winters will be, well, if we're closer to the sun, would the temperature go up a little bit or down a little bit? It's an easier way to ask it. If we're closer to the sun in the winter, our temperature during winter will be a little bit higher than it could have been during winter. So what that means is that for us here in the northern hemisphere, because we're closer to the sun during the winter, our winters are not as cold as they could have been. Okay? And on the other hand, see if we can use that explanation I just gave. If we're farther away from the sun during summer than we usually are here in the northern hemisphere, what is that going to do to our summers? They're not going to be as what? Our summers won't be as it's okay. Our summers won't be as hot. So for the northern hemisphere, because of the placement of the sun, our winters are not as cold as they could have been because we're a little bit closer to the sun. And the summer is not as hot as it. I know summers in Florida feel terrible, but they're not as hot as they could have been because we are a little bit further away from the sun. So the distance to the sun has a little bit of an effect on the temperature, but it's not really that much. But what does that mean for the southern hemisphere? That means that the southern hemisphere is farther away from the sun than usual in the winter, so their winters are colder than ours. And the southern hemisphere has summer when it's closer to the sun, so that means their summers are hotter than ours. So the southern hemisphere has more extreme seasons than the northern hemisphere because of the distance to the sun. Summers are hotter, winters are colder. Okay? Now, so somebody's talking about because of the slow precession of the Earth. Remember, the pole is slowly changing position over thousands of years. So that does mean that the temperature during the winter and the summer does slowly change over thousands of years. But it's not something you would be able to notice. That kind of trend would not be something you can notice in your lifetime. And it just goes back and forth. Oh, and by the way, that's nothing to do with climate change and global warming that we're talking about right there. That's a totally different thing, which we'll talk about.